Now let's talk about mean life of radioactive substance, or it's also called as average life of radioactive substance. And this mean life is symbolized as tau, and and this tau is it is basically sum of all lives of all nuclei divide by total number of nuclei present. So we can say that this mean life of a radioactive substance is given by the sum of total life time of all the nucleuses divide by the total number of nucleuses that are present in the sample. And to, to represent this sum of all lives by T, and this is my N naught. So this mean life of radioactive substance can be written as T total by N naught. So this is how we define this physical quantity as mean life of radioactive substance. And a radioactive substance takes it certainly takes infinite time to disintegrate completely. So it disintegrates continuously till all the nuclei of the substance uh, disintegrate into their daughter nuclei. And what does this show to us is that every nucleus has different lifespan. And, and in order to calculate this mean life of the radioactive substance, uh, we take sum of lives of all the nuclei that are present present in the sample, and divide it by the total number of nuclei of that sample. So this mean life that we have, it measures the average time for which a radioactive substance exists. So this star is the average time for which a radioactive sample that we have it can exist. So to have the expression for this mean life, what we will do is we will assume the same equation where we have n equal to n0 e to the power of minus lambda t. All right, and N0 is what? It is the total number of undecayed nucleuses at T is equal to 0. So, so that is that gives us the measure of this N0. Now, after T, when there is some time T going on, we have the relation for decayed and undecayed nuclides. Now, in this equation, what would I like to do is, I would like to differentiate this equation. Differentiate with respect to time. So what is the aim? The aim is to have an expression for this average lifetime of a radioactive substance. And what does that mean? It means how much time the radioactive substance will take in order to get completely converted or disintegrated into the daughter nuclides. So to differentiate this equation, what we'll have is we will have dn by dt, and then on the right side we will have minus what is it? It is what is it? Come on, it is lambda. It is d by dt of n0 e to the power of minus lambda t. Okay, that's the case. because we have n equal to n naught e to the power of minus lambda t. Now, what we have done is we have differentiated this with respect to time. So what we will have is dn by dt is minus lambda and naught. The differentiation of exponential function will give us exponential function, and we have to multiply it by the internal derivative of minus lambda t with respect to time, and that comes out to be minus lambda. So dn by dt is minus lambda and not e to the power of minus lambda t. This is because d by dt of e to the power of minus lambda t is e to the power of minus lambda t into d by dt of minus lambda t. So that is minus lambda e to the power of minus lambda t. So that's what we have achieved here. And to move on from here, so if I can write it like this dn is minus lambda and not e to the power of minus lambda t dt, where this dn that we have, therefore I would say that this dn is the total life. It's the total life, uh, uh, total life lived for time t. So if I multiply this number by t, that's going to give me the total life lived for the time t. So that is going to be dn times t. So this dn times the total time will give me the total lives lived for the time t. That should be the case. So what am I doing here is I'm taking magnitude of dn. So dn t is going to give me the total time, because time cannot be negative. So the total life lived for the time t will be dn times t. So in order to get that total time now, what should I do is I would like to integrate that equation. So what would suppose that t total, if I had to write it mathematically, it will be integration of this t dn. And what will be the limit of integration? It will start at n is equal to n0, and it will end at n is equal to 0. Certainly that's going to be the case. So what we have here is when n is equal to n0, t is equal to 0. And when n is equal to 0, this t is going to be infinite, because this is going to take the infinite time. So what will happen to this t total equation? This t total will be it will be integral t dn mod from 0 to infinity. That should be the case. Now what would I do? I will use for this, I have dn is this much, but I want to use mod of dn. So what will be that? That will be integral 0 to infinity. That will be lambda n0 e to the power of minus lambda t, and this whole thing is multiplied by this t, and we have dt there. Okay, that's the case. So here I have total, the sum of all lives lived. So what am I supposed to do is I got to integrate this, and certainly I will use integration rule uv here. So what will be outside the integration, first of all, is lambda and n naught. So I can write here this t total that I have. It will be lambda and naught will be out. So inside I'll be left with 0 to infinity. Then n is out. Then t times e to the power of minus lambda t dt. So what am I supposed to do now is to integrate it. So t total will be coming as and not. So we have to use the UV rule here. So what we have is t as x into integration of e to the power of minus lambda t, that's e to the power of minus lambda t, divide by the internal derivative of lambda t, that's minus lambda. So what will be the limit? That will be 0 to infinity. Then what we will have is minus integral of differentiation of t, that is 1, and integration of e to the power of minus lambda t by, that will be e to the power of minus lambda t by minus lambda 0 to infinity. Okay, so what will be t total here is lambda and naught times. Now this thing is immediately equal to 0, because at infinity you will have 0 and this whole term is going to die. So what will be left with is minus. So this is minus minus will make it plus. So integration, so what we have lambda out. So inside I have to integrate it again now with respect to time. So it will be again e to the power of minus lambda t by minus lambda, and the limit of integration will be, it is integrated, so the limits will be 0 to infinity. All right, so what I will have is total. Yes, here I have, I'm using, here I will have this, this minus will, this minus will be converted into plus, okay, by the first integration. And for the second integration, what I'll have, will go with that. So here I will have lambda out. So I'll have lambda and naught by lambda square minus is out. Okay, inside we are left with e to the power of minus lambda t. So this is e to the power of minus infinity minus e to the power of 0. So t total, we will have this square and this will go. So this is n0 by lambda. Now this is minus outside. So what will happen? This thing is 0, this is 0, minus is outside, minus e to the power of 0 is 1. So this t total that we have got is this total time, the sum of all the lives lived by all the nucleuses, that is coming out to be n0 by lambda. So now we can have an expression for tau. And what is tau? Tau is the mean life or average life of radioactive substance. And we have already defined it, it mathematically. And what's that? It is T total. It is T total divided by N0. So this T total is calculated as N0 by lambda N0. So this N0 will cancel. So we will have tau is 1 by lambda. So this average life of radioactive substance is simply the reciprocal of distinguishing constant. And I can also generate a relation between this average value and half-life. Here I can proceed with what I have T half. Half-life is, it is 0.6931 by lambda. So that implies lambda is T half by 0.6931. I can use this lambda in this equation, and I can have a relation between mean life of nuclei and so this is 1 by, so what will happen? 0.6931 will go up, and I will have T half at the bottom. So this is giving me the relation between the average life and the half-life. So for T half, is it right? Yeah, this is right. So this is for lambda. Here I have to use T half. 0.6931 will go up. Something is wrong. Is it okay here? This is T half, and so T half is 0.6931 by lambda. So and tau is it is 1 by lambda. So I have for lambda I have T half. Lambda is here and T half is coming down. I have written it reciprocal, huh? So it is 0.6931 by T half. So so here we will have, okay, what we will have is what we will have is, we will have tau equal to, what's that? That's 1 by lambda, that is 1 by 0.6931. uh, T half will go up. T half will go up. Uh, that should be the case. So this tau will be, and we will be T half by by 0.6931. So this is our final relation that correlates between the average value of all the nucleuses, average life of all the nucleuses in a sample, and the half life of the same sample.